Hello, today we're going to do our second day of simplifying exponents. Today it says apply exponent properties involving quotients. So last time we did involving products, which was multiply. Quotients is when we are now dividing. We have a division or this line in there. So it says simplify the expression and write your answer using exponents. Okay, so we don't want just a big old number. We want the exponent there still, just simplify. So if we simplify what's in the numerator and what's in the denominator, in the numerator we have 8 10 times, or 8 times 8 times 8, 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, we gotta get one more in here, 10, oops, where's 10, oops, times 8, and on the bottom we only have 8 4 times, 1, 2, 3, 4. So how do you simplify this? Well, we could just simplify it right back to 8 over 10 and 8 over 4, or 8 to the power 4. We don't want to do that though. Remember, back when we learned how to simplify numbers, 8 divided by 8 is the same as just 1. So here, 8 over 8 is just 1. So this is really 1 times 8 over 8, which is 1, times 8 over 8, which is 1, times 1. So 1 times 1 times 1 times 1 is just 1. So all of our denominator is now gone, and we just have this many 8s left on top. We have 1, 2, 3, 4, 5, 6 8s left in the numerator, so we have 8 to the power of 6. And on the bottom you could have 1 times 1 times 1 times 1, but you don't really need the divide by 1. 8 to the power of 6 is still 8 to the power of 6. Let's simplify the next one. This has, I'm going to do it down here, negative 3 9 times, negative 3, negative 3. Notice I'm putting the parentheses on it. It's not just 3, it's negative 3. There's 4, 5, 6, 7, 8, 9. Barely fits there. And then on the bottom I only have 3 negative 3's. 1, 2, 3. So 3 over 3, just like 8 over 8, makes 1. So we have 1 times 1 times 1. So how many negative 3's do we have left? Well, we have 1, 2, 3, 4, 5, 6 negative 3's in the numerator. It's just 1 times 1 times 1. You could put it over 1, but this is the same as negative 3 to the power of 6. Now, some of you might be thinking, Miss Calc, you can just take 10 minus 4 to give you 6, and 9 minus 3 to give you 6. And yes, you can. There were more negative 3's on the top, so this is on the top. We'll do it in a minute on the next page where there's more negatives, there's more numbers on the bottom, and you'll see what that looks like as well. So right now we have 5 to the power of 4, so 5 4 times. 1, 2, 3, 4 5s. That was that first one. And over here we also have multiplied by 8 more 5s. 1, 2, 3, 4, 5, 6, 7, 8. And then in the denominator on the bottom we have 5 7 times. 1, 2, 3, 4, 5, 6, 7. So if we simplify some of these make 1 times 1 times 1 times 1 times 1 times 1 times 1. Those ones cancel out. And we're left with 1, 2, 3, 4, 5 5s on the top. 5 to the power of 5 on the top. You could put it over 1, but we don't need to. 5 divided by, or 5 to the power of 5 divided by 1 is still 5 to the power of 5. We're just simplifying, making it look a little bit nicer, smaller. Now, if we have one that's a fraction, we need to make them both fractions. Just like if I multiplied 1/2 times 8, you might want to make it both a fraction so you can multiply straight across the top and the bottom. That's what we're going to do here. This is technically x to the power of 6. I'm going to put it over 1 so we can multiply straight across the top and the bottom. 1 times x to the 6th is still x to the power of 6. X to the 4th times 1 is 1x to the 4th, or just x to the 4th. So if we simplify these, or write it out, this is x 6 times. And on the bottom this is x 4 times. Well, if we simplify those, x over x is just 1, just like 5 over 5 or 3 over 3. 1 times 1 times 1 times 1 Oh, we're left with only x to the power of 2 on the top, which is really just x to the power of 2. X squared. Now, same thing, but we're going to apply some of the things that we learned the other day. Whatever's in the parentheses here, we need to write 3 times. So this is really, I'm going to just put the negative on the top, pick the top or the bottom, but not both. It's really negative 5 over y 3 times. Negative 5 over y, negative 5 over y. So if we simplify this, well, this is really negative 5 how many times? Well, 1, 2, 3. 5 3 times. And this is y 3 times as well. So this would be a nice answer. However, if we have numbers and letters, we can simplify the numbers a little bit. So negative 5 3 times, a negative times a negative, we know it's going to make a positive. 5 times 5 is 25. But then times negative 5 again is going to give me a negative 125 on the top, and then y to the third on the bottom. So these are the same. This one is just simplified in terms of the numbers. So now you know with the exponent on the outside of a fraction, really both pieces get that exponent. So for example, this is the same as a over b written 2 times. A over b times a over b. Well, how many a's are there? That's a times a, which is a squared, and b times b, which is b squared. We can't simplify that any further. That's it. So really the a got the power of 2 and the b got the power of 2. Same thing here. This is x over y 3 times. X over y, x over y. So x times x times x is really x to the power of 3. And y times y times y is y to the power of 3. They're all letters. You can't simplify. That's it. Same thing like this first one up here. I'm just going to put the negative with the 7. So we really have this whole thing 2 times. Negative 7 over x times negative 7 over x. So we really have negative 7 2 times. Notice always put the negative numbers in parentheses there. And x times x is x squared. So this is technically an acceptable answer, but negative 7 2 times, negative 7 times negative 7, should make a positive 49. So this would be an even better answer. Alright, flip over to the next page. Same exact type problems, except as you can see, as you notice, there's a lot more going on here. This is why we learned how to write this out 3 times, is because some people are going to mess up distributing this 3 to everything inside there. So I'm going to write this out 3 times. All that's in here. So we have 4x squared over 5y 3 times. 4x squared over 5y. 4x squared over 5y. I wrote it 3 times. And now I'm just going to simplify. I know I have, this is all multiplied, 4 times 4 times 4, which is 4 to the power of 3. And on the top I have 2x's here, 2x's here, and 2x's here. So 2 plus 2 plus 2 give me x to the power of 6. If you're not sure, you can write those out. X, that's really 2x's, this is 2x's, and this is 2x's. On the bottom, 5 times y, 5 times y, 5 times y. So we have 5 times 5 times 5, 5 to the third. And then y times y times y is y to the third. So again, if we wanted to, this could be an okay answer. However, a better answer would be to simplify our numbers right here. So 4 to the power of 3, well, 4 times 4 is 16. 16 times 4 might be one you want to plug in your calculator. It would be 64, x to the 6th. And then on the bottom, 5 times 3, not 5 times 3, 5 to the power of 3, never 5 times 3, no, no, no. This is 5 3 times, 5 times 5 is 25, times 5, which would be 125. And then there's y to the third. So this would be our best answer. And I just almost made a mistake. Don't ever multiply 4 times 3. That's not what this is saying. This is saying 4 3 times. That's why I multiplied 4 times 4 to get 16, times 4 to give us 64. All right, let's try the next one. We have this whole piece 2 times. So x squared over 4 times y 2 times. X squared over 4y. Well, this is really 2 x's, and this is really 2 x's, so we really have 4 x's there. And then on the bottom I have 4 times 4. You could write 4 squared, but 4 times 4 you know hopefully is 16. And then on the bottom, y times y is y squared. So we have x to the power of 4 over 16y squared. Next, this part's in parentheses, so we need to write this part out 5 times, and this is just 1 time. Just write it like it is. So we have a squared over b 5 times, a squared over b, a squared over b, a squared over b, one more, a squared over b. And then we have this other little piece here, times 1 over 2a squared. So let's simplify this. I know each of these is 2 a's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 a's on the top. A to the 10. And there's a 1 there. You could put the 1, but we don't really need times 1, because a to the 10th times 1 is still a to the 10th. So I'm just going to erase that 1. And then on the bottom, oops, we have b times b times b times b times b, which is b to the power of 5. But we always write our terms in alphabetical order. We also have a 2 on the bottom, and we have an a squared, because that's 2 a's there. So this would be an okay answer. However, I would not accept it because we have a's on the top and a's on the bottom. We need to simplify this. I'm just going to rewrite this up here. We have a to the power of 10 over 2a squared b to the 5th. So if we have a's on the top and the bottom, we could have canceled them out right away. 2 here and 2 here would go away. Just like a over a would cancel out, 2 a's would also cancel out. So those would go away, and instead of 10 on the top, we'd only have 2, 4, 6, 8 a's. So we have a to the 8th, and then over 2, b to the 5th. If you ever have the same letter in the numerator and the denominator, some of them will cancel out. So let's take a look at this next one. As you can see, right away, here's a t on the bottom and a t on the top, so I know, just like this one, something's going to cancel. So I'm going to write this out 3 times. 2s over 3t, 2s over 3t, 2s over 3t, and then times t to the 5th over 16. So I know I'm going to simplify. I'm going to do my numbers here first. 2 times 2 is 4, times 2 is 8. If you wanted to write 2 to the power of 3 for now, that's fine as well. And then on the bottom, just my numbers, 3 times 3 is 9. 9 times 3 is 27. So those got me 27, but I also have to multiply by 16. So that's what I would probably plug in my calculator, because I don't know 27 times 16. It's going to give me 432. Kind of a big number, but for now, just leave it like it is. So we've taken care of the 2's and the 3's and the 16. So we have left on the top s times s times s, which is s to the power of 3. Before I count up my t's, I have 5 t's on the top and 1, 2, 3 on the bottom. So a t on the top and a t on the bottom can cancel. So 2 are gone, 3 are gone. That leaves us with 2 t's left over on the top, or t squared. So my answer is 8 s to the 3rd t to the power of 2 over 432. However, this is one thing I would check, that I can simplify these numbers. Can I divide these by anything? Can I divide by 8 maybe? Yes, I can. So if I divide this by 8, this is technically in the wrong order, divide by 8, divide by 8, it should give us, 8 divided by 8 is 1, or just 1s to the third t squared, and 432 divided by 8 is 54. So s to the third t squared over 54 would be our best answer. Again, always simplify your letters in the top and bottom before you give me your final answer. Alright, a couple more like this. This first one is not a fraction, but the second one is. So I'm going to make them both fractions. So I know this is z to the 8th on top, times 1 is just still z to the 8th. And then 1 times z to the 7th is still just z to the 7th. Some of you may be able to see this, but we know most of the z's are going to cancel out. 4, 5, 6, 7, 8. So we have 1, 2, 3, 4, 5, 6, 7 z's that are gone. So we just have one z on the top. So z divided by 1 is still just z. So hopefully you can see that most of them, 7 and 8, they're going to cancel out, just leaving us with a z. Now this next one might get a little bit tricky. Because I have a fraction here, I'm going to want to have this as a fraction as well. So I'm just going to write this as 4 to the 9th over 1. And then I need to write this piece in parentheses 5 times. Negative 1 over 4 times negative 1 over 4, negative 1 over 4, negative 1 over 4, one more time. So let's do some simplifying. I have lots of 4's. On the bottom I have 1, 2, 3, 4, 5 4's. On the top I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5 of them are going to cancel out. So that's those 5, and they'll leave me with 4 left over. 4 4's on the top. And then on the bottom, I have no 4's left over. I just have a 1. So I've taken care of the 1, I've taken care of all the 4's. All I have left are all of these negative 1's. Well, negative 1 times positive, or a negative times a negative makes a positive 1. Times a negative is a negative 1. But times another negative, 2 negatives again make a positive. So there's 1 negative left over. So 1 times 1 times 1 times 1 times 1 is still 1, but now it's just a negative 1. So this is just times a negative 1, which is really just a negative 4 to the 4th. Now, leave the negative out front. You do not need these parentheses, because then that would be negative 4 instead of a positive 4. So if that part's confusing, let me know. So make sure that negative is out there. So this is your answer. The negative 4 to the 4th, whatever 4 to the 4th is, divided by 1, which you could just leave it as negative 4 to the 4th, because dividing by 1 won't really do anything. Alright, 2 more like this. I'm going to write everything out just as I see it. Negative 5 over x, 2 times. Negative 5 over x, negative 5 over x. And then I need to write this piece out 2 times as well. 2x to the 4th over y to the 3rd. 2x to the 4th over y to the 3rd. I wrote that 2 times, and I wrote this 2 times. So now let's simplify. I'm going to do the numbers first. A negative 5 times a negative 5 is a positive 25. 25 times 2 would give me 50. 50 times 2 would give me 100. All I did was multiply all of the numbers. Negative 5 times negative 5, then times 2 again, gives me 100. Then I need to simplify my numbers. I have 1x here, but 4 here and 4 here. So 2 of these are going to cancel out with maybe 2 of these. So we have 4 and 2 more left over on the top, so the x to the now 6th. And on the bottom I have 3 y's here and 3 y's here, so that's a total of 6 y's. I can't simplify anything else because the x's and the y's are all together where they should be. and 100 is just 100. All right, last one. We have this whole piece 3 times. 2x to the third over y, 2x to the third over y, 2x to the third over y, and then times the last piece, which is 1 over 6x to the third. So when I simplify here, my number is 2 times 2 is 4, times 2 again is 4 times 2 is 8. On the bottom, we just have a 6. So I've taken care of all those numbers. And then if you cross them out like that, maybe that's not the best idea. So instead, maybe I'm going to just undo that. Oops, too much. Because then it looks like I canceled it. And I didn't want that. I just wanted you to know that I took care of all of those numbers already. So now I just have to deal with my x's and my y's. Well, the y's are only on the bottom, so y times y times y, that's 3 y's. And my x's, I have 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here, and 3 down here. So these 3 might cancel out with these 3. So those are gone, and we only have 1, 2, 3, 4, 5, 6 x's left on the top. So this would be a great answer. However, I can simplify 8 divided by 6. I can divide those both by 2. 8 divided by 2 would give me 4. 6 divided by 2 would give me 3. And then x to the 6th and y to the 3rd. Those don't change, only the numbers, because I simplified by dividing by 2. You can't simplify the x's and the y's because they're different letters. So last problem. It says solve a real-world problem. The luminosity in watts being like how bright a star is. Watts, just like a wattage in your light bulb, tells you how bright the light bulb is going to be. So the luminosity in watts of a star is the total amount of energy emitted or coming out of the star per unit of time. So as seconds go on, it tells you how much light is being pushed out from the sun. It says the order of magnitude of the luminosity of the sun is 10 to the 26th watts. The star, Canopus, is one of the brightest stars in the sky. Cool, but we don't really need to know that. It just tells us now that the order of magnitude of the luminosity of Canopus is 10 to the 30 watts. So the sun is 10 to the 26 watts, and the star Canopus is 10 to the 30 watts. How many times more luminous is Canopus than the sun? Well, Canopus, we just said, was 10 to the power of 30, and the sun was 10 to the power of 26. So they're asking us how many times more luminous, or how much more bright is it? Well, this one was only to the power of 26. This is to the power of 30. So you guys, I could write this out 30 times and write this out 26 times. But how many more 10s would there be? Well, there would be 4 more 10s in Canopus, which is really 10 4 times, 10 times 10 times 10 times 10, which is really 4 zeros. 1, 2, 3, 4. So it is 10,000 times more luminous. So this would technically be an okay answer, but they might write it as a big number. It is 10,000 times more luminous because it's multiplied by 10 4 more times. So we learned now again how to simplify using exponents. You can start the front side. It says only do 1 through 18, 20, and 21, which literally just means skip number 19. If you have any questions, let me know. Otherwise, good luck.